Okay, hello everyone. Today we'll be discussing something called a sliding window flow control mechanism. Okay, before I move on to this topic, I'll just revise what we had done for the last class. Okay, we had already studied something called as stop and wait flow control mechanism, and we had seen how it works, and then we had also derived something called as link utilization, and we had seen how good or bad it is. Okay, I'll just revise for you all. Okay, now in this method, there is a sender, there is a receiver, and then here the frames are not numbers. Only one frame is sent at a time, so the frames are not numbered over here. Now what is happening is that the sender is sending one frame, and the receiver receives it. And if it receives properly, it will send an acknowledgement. Now this method is designed in such a way that till time the sender does not receive the acknowledgement for the frame that it has sent, it will not send the next frame. So it has to wait for the acknowledgement to come over here. And then we discuss something called as link utilization. Now if you calculate this properly, you will find out that the link utilization efficiency is very poor when the time to transmit this frame, that is TF, is significantly less than the propagation time. Now here what is happening is that if you compare TF with the propagation time, that is TP, you see that a lot of time is getting wasted in simply propagating the frame until time and then the station remains idle. It cannot send the next frame. Only after the acknowledgement reaches from the receiver, then only it sends the next frame. So the link utilization efficiency is very poor over here. So they came up with something called a sliding window flow control mechanism. Here yes, it is slightly different than the previous method in where here all the frames are numbered. If you see here D1, D2, D3 and D4, then all numbers are given to the frames. Okay, they are numbered, and then the sender keeps on sending the frames without actually receiving the acknowledgement for the frames that it has sent. Okay, so here it is like a D1 frame D1 is sent, frame D1 is sent. Okay, it is received. Frame D2 is sent, it is received. Now this receiver can send acknowledgement after D1 also and after D2 also. It depends on the receiver when it wants to send the acknowledgement. Okay, now here the acknowledgement is slightly different as compared to the previous. There it was acknowledgement and wait acknowledgement. Here there are two similar kind of acknowledgement which are sent by the receiver. Okay, the first one is called as RRN. It stands for receive ready N, where N is the sequence number of the next data frame the receiver expects to receive. It simply means that it's very simple, no need to get confused. Now I'll just take one nice example so that everybody understands what I'm talking. So we have a sender, we have a receiver, and then the sender has a buffer over here where some frames are kept which this fellow wants to send. Okay, so there are more frames also, but only this buffer can accommodate only 4, so only 4 are seen here. So what does it do? It sends D0. Okay, A sends D0. It is received by B. Okay, then this fellow B doesn't send the acknowledgement. At the same time, A also sends D1. Okay, when it receives D1, B sends acknowledgement RR2. Okay, R stands for receive ready to. Okay, now it has very nice meaning. Okay, RR2 means what? Now the receiver wants a frame number 2. That is one thing that it is trying to tell with RR2 to the sender. The second thing, it also tells that it has properly received 0 and 1 frame, that it has received D0 and D1, and it is requesting for D2. Now by that time this fellow reaches to the sender. The sender had already sent D2. It doesn't wait for the acknowledgement to come. Okay, so D2 already reached over here. Okay, now if you see one important thing in this slide is that now if you see the buffer over here, okay, the buffer has D0, D1, D2 and D3, and the buffer now in this also the buffer has D0, D1, D2 and D3. Now even though it has sent D0 and D1, it still keeps D0 and D1 over here. The reason is that this frame when it is sending might get lost over here. okay, and then the receiver might ask the frame again, so it has to keep those previous frame till time it is acknowledged or the receiver sends the acknowledgement. Now if you see here over here, now it is received after this fellow sends D2, okay. So if you see the buffer over here, it has still D0, D1 and D2, and after this time it received RR2. If you see this buffer, it will not have D0 and D1. Why so? Because it received RR2. What this RR2 told the sender? It told two things: send me D2, one thing, and second important thing, it told us told the receiver it told the sender that it already received D0 and D1. So this fellow did not keep the frames in the buffer and can remove it from the buffer, and then new frames can come. Now if you see, new frames are coming in the buffer. Okay, now we'll see, continue over here. Now the sender sends D3, okay, and receive and D3 is received over here. Now if you see over here, after it received D2, it sends acknowledgement, something called as RR3, meaning it wants 3, but something happened and then this RR3 did not reach the sender, but it is okay if it not reach. The next consecutive RRs will acknowledge the previous frames. So what happened over here is that D3 is sent, D3 is received, D4 is sent, D4 is received, and after some time, and then this value is sending RR5, and RR5 means that it wants 5, and then previous all D0, D1, D2, D3 and D4 is received properly, okay. And what happens is that the sender is also sending D5, and then it received D5 over here. Okay, when this RR5 is received by the sender, okay, what it will do is that it will remove all the frames which are there in the buffer. Which one it will remove now? It will remove D0, D1, D2, D3 and D4. Okay, if I had to draw a buffer over here, it will have not had from D0 to D4. So this is simple. Now this RR is similar to acknowledgement which is there in stop and window. There is one more acknowledgement, something called as RNRN. RNR stands for receive not ready N. Okay, now it is similar to that wake acknowledgement which was there in stop and wait flow control mechanism. Okay, now what does RNR mean? Okay, it's RNR means that it has received all. Now suppose I take one example, RNR2. So it will tell the sender that it has received 0 and 1 and it does not want 2. So RNR2 tells that it does not wants 2. Okay, so when does the sender start sending the frames again? See, after the receiver has sent RNR2 and this RNR2 reached the sender, that is A over here, what will happen is that it will understand that it doesn't want more frames, it is telling it to wait. Okay, so now when it will start transmission sending the next frame, when B will send RR2 to A, and when it receives RR2 after RR2, then it will start sending the next one. Then it will send D2, D3, D4, something like that. Okay, good. Okay, one important thing now, one question can come for a semester exam, why it is called as sliding window. Now you consider any buffer, that is at the transmission sending end or the receiving end. You take the sending end buffer. Now the sending end buffer is it looks something like this, where there is a window. What is this window? Now it is a space where the frames are kept. Now which kind of frames will be there in this window? Two kinds of frame. One is the frame that is actually going to send, and second type of frame that it will have over here is that it will have frames which are already sent, but whose acknowledgement is not yet received from the receiver. Okay, so we just assume that if this is the frame which is already sent, but his acknowledgement is not yet come. So after some time, when the acknowledgement comes for this particular frame over here, what it will do is that it will remove this frame from the window and it will put it out keep it out from the window, and this window will slide and it will bring this particular frame inside this window. That's why it is called as sliding window. So it is sliding like this. Okay. Now what will be this frame? Now it will be a frame which is sent and also acknowledged by the receiver. Okay. And what will be this frame? Now these frames which are waiting to be waiting to enter the window. That's why it is called as sliding window. Nothing great. Okay. Next, now this is something important is going to be asked. Okay, what kind of frames? Now one small thing, some technical things which are there. See, now we have the same sliding windows, and okay, and the frame number and the frames are numbered. This is called as DN. This is DN plus 1, DN plus 2, DN plus 3, DN plus 4, DN plus 5, and DN plus 6. Okay. Now this edge, this upper edge, so we have called two edges. Okay, this is the upper edge. This is called as upper window edge, and this is called as the lower window edge. Okay, some technical things that you should remember. So we have when there is a window, we have lower window edge, and we have the upper window edge, and then this is the actual window. Now the same thing will be there at the transmitting at the sender as well as the receiver. Now at the sender, what kind of frames will be there in the window? Just now we have discussed that at the sending end, it will have two kinds of frames. One, frames which are yet to be transmitted, which it has to transmit. Okay, and also it will have frames which are actually transmitted but whose acknowledgement has not yet come from the receiver. Now what will be this frame? Now it will be the frame that is transmitted and whose acknowledgement is received. Okay, and what will be this frame? Now this will be the frames which are yet to enter the window. Now at the receiving end, what kind of frames will be in the window? Now data frames which can be accepted, or frames which are already accepted by the receiver but acknowledgements are not yet sent. Two kinds of frames which can be accepted, and frames which are accepted but whose acknowledgement are yet to be sent. Okay, and what will be these frames? These frames will be frames that cannot be accepted, and these frames will be what? Now the frames which are received and acknowledgements are already sent. Again, this is a small example. This is a good example wherein we will revise everything. So we have sender A and we have a sender B. Okay, we have a window at the sending end, and at the receiver also we have a window. Okay, this is upper window edge, lower window edge, and upper window edge. Okay, now we have so many frames in the window, and then there are frames wanting to enter the window. So it is sending D0, it is receiving D0. Received, it is sending D1, it received D1. Okay, and then it sends RR2. After some time, this fellow also will send D2, and it is receiving D2 properly. This fellow receives RR2 from the receiver. So it understands now. If you see here that D0, D1 is already is still there in the window. Only after it receives RR2, it understands that the 0 and 1 was properly received. So in this particular window, it will not keep D0 and D1, and it will keep on sending D3 next frames and D4. Okay, hopefully everybody has understood this particular topic. Thank you very much.